Hello, statistics student. This video is for chapter 1.2, and we are doing the third part of the 1.2, which is looking at sampling method, types of samples, and properties of samples. The first things we want to talk about is what are the different types of samples and what are they? The first types of sample is random samples. We mentioned that samples are just a subcollection of data from population. So random samples are supposed to be the one that is representative because when we select them, we try to make it so that all possible groups of samples is possible. So if your sample size is n, which is what we normally do, if you see the variable n, usually that is the sample size. If you are to select n individuals or n subjects from the populations, so a simple random sample would be such a way it is selected in such a way that any groups of n individuals are equally likely to be chosen. So the methods to do this is called a simple random sampling method. The second types of sample is also a random sample, but the requirement is less strict, is that every subject has a chance of being selected. So long as everyone has a chance of being selected, well, we might not select everyone because we cannot. But if everyone has the same chance or has equal chance of being selected, that sample is a random sample. Both simple random sample and random sample are representative sample because they should have a similar characteristic as the population. Non-random samples are the one that you just select by convenience, or you let the subjects to volunteer. So we call them volunteer response sample. So those are non-random samples. Not all subjects have equal chance of being selected. So a good sample should have the same characteristic as the population, and it is representing. So we say random sample or simple random sample can achieve this goal. So when we say random samples in English, random means out of, not planned it. If you say I want to pick something to read, I'm going to pick a random book to read. You just walk into the library and pick up a book, or you at home you look at your bookshelf and randomly pick a book. So that's how we mean by random in English. But in statistics, random means it is not determined by your own will or any personal choice, or it has to be determined by chance. So how do I determine this by chance? So when we say random sample, the chance thing has to be controlled by something that is really random, in that it is controlled by a random generator, or by a random process where you put all the names in a hat and you randomly pick them. So let me show you how to select a random number generator. So what you can do is random number generator. If you do this, this is a random number generator. It tells you that you can pick a number from 1 to 10 randomly. The system itself will randomly generate it. So if I am to pick, say for example, I have around 30 right now. Is it 36 or 37? I don't know. 36 students. I'm going to randomly select one of you. I will click generate, so that I do not do it myself. I do not I think of a random number randomly, because if it is human, anytime we have human intervention, we tend to be biased, or we have our own way of doing things that might not be random. So you need to depend on a random number generator to do that. So the next number will be 13. The next would be 22, like that. So random number generator. How they do it? You can they do it through math. So you can, if you're interested, you can look at. You can Google. I'm sure you can find out. You can also find this by a calculator. So here I have a calculator online. If you have a TI 83 or 84, you can have a calculator like this, and you turn it on. So under math, probability, probability because random number is chance, right? So ran integer. So ran is also a random number, but I think ran integer is easier. So ran integers ask you to pick a number from, for example, 1 to 40. Okay. Pick one number, 40. Okay. And then you press enter. They will give you a number, 13. Press again, 4, 40. So these are called random number. That means when you pick your subject, you pick the label by a random number generator choose it for you. So that is random uh, random sampling. So what about stratified? Okay, so this is the way to the name of this method is called simple random sampling. You pick each one by one. So each time you pick one number. So what about if I have a repeat? So we can talk about this. You could not use it or you can use it again. Okay, we could talk about. But when you do one by one, sometimes you get repeat choice. The second way of choosing a random sample is called stratified sampling. So what you do is you divide your population into groups first. You call them strata. And then you take a proportional number from each strata. So that means, that means like you would have a big population, like graphically, you can think of it that way. You divide them into maybe male, female, if this is a human, okay? Or if it's students, you can divide it into like part-time, full-time, and then proportionally, if they're equal, then you randomly select a few from here, you randomly select a few from here. The way you select them, it is through random process also. So put them together, that is your sample. So we call it stratified sampling. The reason why we want stratified sampling is sometimes maybe you would divide them into groups where there is a particular group that has very low number, like for example, like this, 1, 2, 3. One of this group is represented very slowly, very small, proportional. So proportional-wise, they're smaller. So you want to make sure that in your sample you have some representative from here. So what you can do is you would pick like proportionally smaller number here, maybe pick 2, but here you would pick 20 and this you pick 40 or 30 proportional to the size of the population and then put all of this into a sample. So this is then you would make sure that every single category has some kind of representation, and we call it stratified sampling because when we choose them, everyone has a chance to be selected, right? The third one is called cluster sampling, is when you divide your population into groups or cluster, and a lot of time is geographic related into section, which location oriented. So, and then you would randomly pick some cluster. So that means you can think of your populations like this, but you divide them into sections, usually more sections and they are location oriented. So for example, in a classroom, I would say row number 1 is section 1, row number 2, row number 3, etc., or an area in the classroom. And then you would pick some cluster or even one cluster, one or more cluster. But the sample would be everyone in this cluster. You don't pick anybody from the other one. Just this and this or more. So um, the benefit is you don't have to visit that many places to get your sample. So if I want to just interview some students, I don't have to go all over the classroom to collect my data. If I say I'm going to interview row 1, I just talk to row 1, or row 5, I talk to row 5. So it is more convenient for data collection. So remember, you choose all member from the selected cluster, but you randomly pick some cluster. In this case, everyone has the same chance of being selected, but it is more convenience for the researcher. The fourth is systematic sampling. Systematic sampling is you would have a list of all the data that your population. So maybe a name or something. You give them a number, just like when you do simple random sampling, you do have to have a list of everyone. Otherwise, you can't generate random number. And then what you do is you randomly start from a starting point. So maybe you say, okay, I'm going to start from 3. And then you skip every so often. I'm going to skip every 5 until I go to the end, and then I can go back and until you get whatever that you need. So you do not need to run your random number generator so often. Maybe you run once to get a starting point, and then you skip 10th every time you skip 10. And then, so this would be still random. Okay, so this is called systematic sampling. You skip a certain number. This is used a lot in people collecting data on the streets. So what you do is you will stand on the street and you will try to interview people, but obviously you don't randomly generate number, right? So what you do is you say you watch people walk by, and then you would interview every 5th person that walk by. In that case, you don't bias yourself saying that, oh, I'm gonna wait until someone that's friendly to interview them. Okay. The 5th is multi-stage sampling. So sometimes when the population is so large, sometimes you would use multiple times of cluster sampling or cluster and then stratified sampling. So multi-stage, it's combination of the preceding sampling method. The last one is non-random. So this is a non-random sample in that you use data that are very easy to get. Maybe you ask people to volunteer, or you just ask your friend. Data that are easy to get by. So we call them convenient sampling. They are not representative of the sample because not everyone has a chance, right? If those are not your friends, they will not get that sample, or people with do not have strong opinion of a particular issue will not call in. So a very common things that is used in internet poll, really, so every so often Facebook or Yahoo will publish this poll. Do you agree with this measure, or do you agree with this way of the government doing things? So they ask you to participate. So those are voluntary response sample because you yourself decided to whether you want to participate or not. Usually, people with very strong opinion, either very strong against or very for, or they have some kind of financial implication for supporting or non-supporting a particular measure, will participate. So those are not accurate because they are voluntary response sample. They're not representative of the whole population. You can collect all different opinion, but opinion is different from data. Okay, so there's 2 more terms that we want to go over. One is sampling without replacement, meaning you do not replace the subject you select before selecting the next subjects because you want n different one, because you want all n different subject, right? N different students and different numbers. Sampling with replacement is once a member is picked, and the members can go back into the population, so it can be chosen more than once. So mathematically speaking, sampling with replacement is fit a particular mathematical models or fit statistical calculation better. But this guarantee that all subject has the same chance of being selected. But in practice, simple random sampling is done without replacement, and survey are typically done without replacement also because you do not want to have the same person being picked. But if the population is small, sampling without replacement becomes an issue. Okay. So we will continue with the next section on looking at example of classifying the method of sampling.